So welcome to another day of the Huawei and Communications Authority Cybersecurity Bootcamp. We are on day 4, and today we're going to be looking at a number of things with regards to firewalls this afternoon. So we'll be going through the slides, getting to understand what is there within the content. And this is going to be quite helpful because firewalls form the core of security, especially network security. They are one of the few devices in a network whose sole purpose is more of a security orientation rather than transmission of information. So I'd like to make it a bit more hands-on, and yeah, we're going to have a nice session. So let me just ensure I set up some security features here because I've seen some people are starting to think they can do some things. Yeah, somebody wanting to go to the next slide. Nyakundi. Okay, let's go on. I think we did a hands-on on ENSP, unless you're not there. So you can do that. Then kindly let's remain muted. Don't really do this, but you're forcing me to do it. Okay, let's go on. So you can do the chat. I'll be checking the chat somewhere, somehow, so that we can go on well. Okay, I hope I'm audible. I also hope you can see the screen. You can confirm that in the chat so that I can see how many are attentive also. Thank you, Effie, Brian, Joe, Evans, Dennis, Katiku, Mary, Lawrence, Mokiribosi, Thomas, Charity, Victor, Marvin, Kevin Collins, Nanis, Doreen, Kefa, Dicky, Geoffrey. Yeah, thank you. Thank you. I can see Samuel. Good. Hi, Murugi, Joki, and Frederick. Nice. So let's go on. You can check the forward, but basically what we're talking about here, we are going to be looking about the technical specification of the Huawei firewalls. And also we're going to be looking at some of the application scenarios and then kind of networking modes, as well as also a bit of the history. So when you're looking at the objectives, you realize that we need to understand the basic concepts of firewalls. We also need to know how the firewall security policies work, and you need to have a very good command of the security policy configuration, not only in the coding or the configuration perspective of a typical firewall, but also what configuration really does to transmission of traffic. So, so let's start with the overview. So some of the features that a firewall usually has, when you look at it in perspective, a firewall always has a logical area filter. It is also used in hiding the internet structure, for example, making it not really visible to people outside the network, for example, from the internet. Then also another thing is also in providing security assurance and also some proactive defense against attacks, meaning that you don't have to react when an attack has happened. The firewall would actually help you do much more when you are actually about to be attacked. So it will really help you. Think of it like the way you usually have a perimeter fence in your neighborhood, it actually helps you. So there's a question here. Can the traffic that does not pass through a firewall be protected? Maybe you can tell me, can the traffic that does not pass through a firewall be protected? Can it? Yes or no? Is this some Kenya saying no? Collins, Mwangi, York, Effie, Mitich. Major, you're saying it depends. What does it depend on? Kevin, you're saying yes. What? Elvis, you're saying very difficult. Morogi, no. Think of it. Yeah. Can you think of it? Can the traffic that passes through a firewall that does not pass through a firewall be protected? So saying if you have other security measures such as intrusion detection system. So let's look at it in the context of this whole diagram, the way it is currently. Can it be protected? You can see, Lawrence, you're saying when you have a way outside the perimeter, it can be passable. See, Thomas, you're saying no. No, according to the diagram, yes, it can be protected based on the topology you're seeing. So yes, because of this topology, when you look at it, anything that is not passing through the firewall right here is not being protected because it is coming directly, although the router might be configured with some security features, but you already know that that traffic is not quite protected. Evans, you're saying at the router, if the two are different devices, yes, they're different devices, but we're talking about protection. You're talking about some kind of filtering, such that you are sure that the packets that are coming from the internet through to the intranet, that is that LAN, from a user, for example, this can be a good person or a bad person, an attacker or a legitimate user. The only way you can be able to know that traffic, because the router will not typically, although there can be some way of accepting or what can I say, some port forwarding and some closure or something. Yes, some ACLs that can be configured. Yes, Moshiri, but you realize that the file is the one that deals with the filtering, right? The router, that is not its main purpose, right? And there is a way you can actually bypass maybe some of the measures that are put in at the router, right? So when you look at this, let's move on. So some of the times, for example, like there are 3 generations, or can be able to think of it that like classifications of firewalls. One is packet filtering firewalls, proxy firewalls, stateful inspection, and stateful inspection firewalls. And if you have an idea of how these really work, you'll be able to see them in more detail on the other slides. You realize that they are doing the same thing of actually trying to secure the network, ensuring that they secure the network, but the methodology and the technicality is a bit different, right? So when you look at, for example, I can see in terms of the notes, I can see that it says network files can try to protect the network in a distributed manner. What that means is there are some features such as centralized security policies, some diversified security functions, and some maintenance by some dedicated administrators. We had a discussion yesterday about this Sophos firewall, and I think Adewale was trying to get to know how to configure some social media blocking and also acceptance for different groups of people. And some such can think of them as maybe part of what? Stateful inspection, can think of it, or packet filtering, but around stateful inspection, you can think about it on that side. And also, some of the policies can become complicated when you look at it in terms of those firewalls and the policies that you need to set up so that you are able to, because what you may deny someone else, you might need to really allow for another. So you need to really ensure that they don't conflict in a way that it can actually render the firewall useless. So when you're looking at a packet filtering firewall, when you're looking at this diagram, what happens is a packet filtering firewall is not able to really, it actually checks each packet at which layer, the network layer, right? Which is actually the IP, right? Which is the IP layer. And then looking at these, realize that some basic principle is that you need to configure ACLs, as Moshiri was saying, to filter the data packets. ACL stands for access control lists, and they're usually based on the IP address. That is why you're looking at it from this layer, the IP layer. And it is very easy to design and cost effective, but some of the challenges that you have with packet filtering is that the performance may decrease quite a lot, especially when the ACLs or the ACL table becomes very complex or even very long, and it has to check against the file needs to check against each and every rule within that list. And then some static rules cannot meet some of the dynamic security requirements that are usually there. And you realize another thing is that a packet filtering firewall usually does not check the session status or even analyze the same data, which makes it quite easy for attackers to escape from some of the from some of the firewalls, especially when they have the sessions that maybe their sessions have not been authenticated, yet the packets are being allowed to go through because they pass the rules within the access control list. So you should note that a multi-channel protocol, for example, such as the file transfer protocol, we're talking about FTP, you can open several channels to transfer data. You understand, like when you're using something like IDM, you usually see that you can open several channels and download the same content in parallel in different parts. So you realize that it generates dynamic data channel port, and the data channel is performed, data exchange is performed on that data channel. So you realize that it's only the packet headers are checked, and it is checked, and you realize when they're checked, really applies from these three layers, from the TCP to the IP to the data link. Whatever is going on here is none of the concern of a packet filtering firewall. So what about a proxy firewall? A proxy firewall works in this manner. So for example, a computer can send a request for connection. What the firewall will do, it will check, it will do a security check. And if the check fails, the connection is blocked from there on. So after the check passes, it will set a connection with the client, which is this PC. And after the check succeeds, is the connection between between the internet server and the client is set up. That is what you can see here. Then what happens next is that the client will send a packet, for example, for this case, packet A, to the firewall, and then it will actually be re-forwarded or resent or actually sent also again to the to the server. And you realize this, that the server will also send a response, that is the packet B, to the file. Then the file will once again also send the response, that is the packet B, to the PC. Think of it like the way you can think about a proxy server. So it acts like an intermediary, right? And when you realize this one actually applies to the application, it actually applies to the application layer. So here, we looked at the packet filtering working within the IP layer, which is the network layer. But when you're looking at at a proxy firewall, it can actually work very well for application, because it will actually look at the session and also a number of other things within the application layer. So the firewall will actually establish a connection with the real server on behalf of the internet user and forwards the internet user's request, that is, and sends the response returned by the real server. So you'll never really see that real server as a client yourself. So it can actually completely control the exchange of network information and the session process, which can actually achieve very high security. But some of the disadvantages are quite damning, and when you look at it, it can be tricky to think of establishing or deploying a proxy firewall at scale. Some of the things is like, for example, processing speed, and also the other thing is it is quite vulnerable to denial of service attacks. And when you're looking at it, that an application layer proxy must be developed for each protocol. For example, if you're dealing with HTTP, FTP, SMTP, HTTPS, all those application layer protocols, you'll actually have to ensure that you have a proxy for each. And this makes the development period a bit long. And also when you upgrade such a firewall, it becomes quite tricky. So it's not really used that much, but it's very important to know that it is there. Yes, Gift. It can be vulnerable to spoofing, and also it can also be vulnerable to denial of service, because at the moment you flood it with a number of requests, it can go down and automatically there's no access to the internet server. So difficult upgrades and also very slow processing of the connections makes it very difficult. Then comes stateful inspection firewalls. So what happens with stateful inspection? So it is basically an upgrade or an extension of the packet filtering technology. So here packets are now filtered based on their connection status, and each packet is now looked at as one that is not dependent on the other, it is independent. And something like the historical association of packets is considered. Think of it like the way we usually say there's a difference between combinational circuits and sequential circuits. Sequential circuits really must ensure that there is an acknowledgement of the historical status of the circuit. So same case, the same concepts applies here. And when looking at the data flows, all data flows are based on reliable connections. And when you look about reliable connections, which one is more reliable? Is it TCP or UDP? Which one is reliable? You can put it in the chat. TCP or UDP? You can see Murugi, Kenya, Mushiri, Mukiribosi, Major, Vintex, Kipnitich. Why are you saying TCP? Why is TCP more reliable? What does it really make it more reliable than the others? York, yes, I can see. What makes TCP more reliable? Kevin, uh, yes, Major, you're saying yes, it is. It is connection oriented, right? It is connection oriented. UDP is connectionless as long as imefikisha hapo kwa gate. It doesn't care whether it gets going to get to the person, right? So three-way handshake, yes. There's an acknowledgement, Maureen, yes. Mukiribosi, yes, that is the reason why TCP is more reliable, right? Yes. So UDP is just best effort, right? Yeah, TCP works on the three-way handshake, UDP is best effort. Yes, Kenya. That is how it is. So it does, yes. UDP doesn't guarantee any delivery of packets, the packets of data. So you cannot use that. So for stateful inspection, you cannot use UDP. So what happens is, in terms of its mechanism, when you look at this diagram, is it will use what we call a session table to trace some of the activated sessions. And you can see there's some acknowledgement here, and then there's a scene here. So looking at these, for example, like I think this is the source and the destination. And when it gets to this side, this is the source, this is the destination. And also you can see some of the other parts of the packet, which is looking at is historical, right? So you can see if there is some status that is incorrect with regards to the file itself and looking at the state of the packet, it will discard the packet. So there's also some security policy check and also some, which is very important, recording of the information of the session information. So you can see it has very good advantages. It has some benefits. Fast processing of the subsequent packets and also very high security. So you usually have what we call a pseudo UDP session, which monitors the status of UDP connection process. The pseudo UDP connection is a virtual connection established for UDP data flow when UDP packets are processed. Remember, UDP is connection oriented. So again, it still deals with also TCP session and also the pseudo UDP sessions. So, but mostly in terms of transmission of data, TCP is much better. So I can say clarification, does stateful inspection inspect each and every packet independently? Yes, but you realize that what happens is once it has done the initial inspection, the processing of the subsequent packets because of the historical information is much, much faster. But yes, there's that independence. But since there's that keeping of the historical information, it is much easier in terms of matching. And when you're looking at it, because of the status association, you realize that because each packet is being treated as an independent unit, and there's still that historical association, you have to inspect them independent of each other, but you need to still consider how they are associated with each other historically. I hope that really answers you, Mushiri. Yes, they have to be looked at. So when you're looking at the networking modes, for example, you can see there's some two modes here. So you realize that there's this mode, you can think of it as mode 1 and this one as mode 2, right? So you have like an untrusted zone, and then we have a trusted zone, right? And these, I think, is a switch, these are router, and this is the public internet. So in looking at it, what happens is in mode 1, the firewall will only forward packets and actually does not perform any kind of routing. And we realize that the two service networks that is interconnected by the firewall must be in the same. Let me confirm something here first. So this is the first, this is the one that is mode 1, this one is mode 2. So you can see a firewall is located between the intranet and the internet. And what happens is the upstream and the downstream service, for example, that's the interface. So for example, there's this interface you can see here. And then there's also this other interface here. On the firewall, work at layer 3 and must be configured with IP addresses in different network segments. So you can see what happens is there's an interface on the firewall on this side, upstream, and also on the downstream, there's also another interface here. So what happens is this, the firewall will perform routing on the intranet and internet like a router, right? So what happens is here is that in this mode, the firewalls will support some of the more security features. For example, like network address translation. It will also support something like a unified threat management, UTM, mostly known as UTM. And then the other thing that you'll be able to do is it will ensure that the original network, you must ensure that the original network topology has to be modified. So for example, when looking at the internet users, they must modify their gateway configurations, or the route configuration on the router must be modified. For example, here, when you look at it, the configuration in this router and also the configuration for the users, think of the switch having users, they actually have to be modified so that that's some of the things that should be considered, for example, without disrupting the network. So let's look at the difference between this mode, this firewall of networking mode, and this other one. So in looking at the mode 2, here you can see this one had only one firewall. Here you're having two, right? And looking at it, and looking at this, you have like something like forwarding of packets, no routing whatsoever, that is. And in this mode, the upstream and the downstream firewall work at layer 2. So remember here, we work in this mode, the interfaces are working at what? Layer 3, and they also required to have IP addresses. For these ones, they're actually working at layer 2. You can see the interfaces. And then the networking mode, this networking mode actually avoids issues, for example, caused by some of the things such as topology changes. And then you deploy a firewall like a like a bridge, sorry. And then there is no need to modify some of the existing configurations that are there within the topology. But in this case, if there are any changes, they actually have to be restructured. For example, if you change anything on this case, for example, if you change the IP of the firewall, you'll have to redo the configurations of the topology so that packets are routed well, considering the firewall was also acting as a router there. Maureen, you're asking that, do the modes have names? According to my understanding and my knowledge, I know that there's something we have like dual hot standby, right? But this one, according to what we have in this slide, we have two networking modes, just calling it the two modes. Is this mode 1 and mode 2. mode, yeah, which one is, yeah, mode 1 and mode 2. So, but we're going to look at dual host standby. Julius saying, which of the following are default security zones? Are you posting or what? Anyway, let's go on. So Kenya, you're asking about which side? This side or this mode or this mode? Which direction is the intranet that is being protected? So you already know that when the moment you are here, we are in the extranet, right? But the moment you are behind, for example, you can be behind anything that is behind the firewall. This is where you are behind the firewall. All these are behind the firewall, right? That is why you can see they are called the trust zone. And this is also now the untrust. Now we have here as the trust zone. You can see this one is the untrusted zone. So which direction? So, you know, data transmission can happen in both directions. You can be sending and you can be receiving. But this is where traffic has to be ensured that they are clean. It's not malicious. And only the one that it has been authenticated, right? That whatever is coming out from the internet has been allowed into the network. So, so that is what you can see with that in terms of these modes. Always remember that there's one mode that will actually be requiring some topology configurations, and the interfaces of the firewall would actually be operating at layer 3. And then for such a case, you'll be having the interfaces working at layer 2 and really do not requiring the interfaces of the firewall not requiring to have IP addresses. Although in this case, you can see when you're looking at it, yes, so when you're looking at it, you realize that here you see the firewall does not require IP addresses, right, in this mode. But in this case, the interfaces of the firewall, you can see where the IP addresses are being shown, require what? They require IP addresses, right? So this is actually the second mode, and this one's the first, right? So don't confuse. Realize that here the firewall does not require, the interfaces of the firewall do not require IP addresses. And for these, the interfaces of the firewall require IP addresses. And you can see that in different segments. If you look at it very well, let me show you the difference. The different network segments. So you can see this one 10.1 up to in /30. It has been given also now 10.5. And when looking at these ones, 129 and 133, that is a different network segment. Because if you're looking at /30 and you're looking at subnetting, how it works, this is a different network segment. This is a different network segment, right? Yeah. It's okay, Evans. You will try to catch up and see how it goes. So some of the principles of firewall forwarding, let's look at it. Talked about this a bit, packet filtering technology. So when you're looking at receiving, when a firewall is receiving a packet, it actually checks the header and compares it, that header with against some rules. Most of the time, those rules is usually posted and inside what we call an access control list. So looking at this simple diagram, we're having an unauthorized user, right? They are trying to access. The moment that traffic is not following or not accepted by the rules, it is not following specified rules in the ACL, does not really get to the HQ. It is blocked. That traffic is blocked. But you realize that traffic coming from the router to the internet, going through to the firewall, coming from the branch to the HQ is allowed because it matches some certain specific rules. Same case for and you can see it doesn't go through the router. The router is required for routing to go to the internet. Going to the HQ to the branch, same case, it is also allowed. So it's quite easy to understand packet filtering, how it works. But remember that sometimes it can be tricky to deal with it, especially when you're having a large access control list, becomes tricky. So, when looking at security policies, most of the rules usually are focused on packet filtering. And you're looking at these, there are specific rules that needs to be followed. And if they match, if the header is done according to the rules, you'll be able to look at these security policies control traffic. So you can see what is written here. Security policies control traffic forwarding according to specified rules. So traffic is only forwarded when specified rules are met. And also there's also an application of what we call integrated content security detection to the traffic. So what are the major applications of these firewall security policies? So they're used to really control network communication through the firewall. And also, again, it is also used to control access to the firewall itself. So I talk about, like, there's that network communication when it is going out, in and out the firewall, and also how are you able to access. So let's look at this example that is here. So having something like 3 steps. So you're having these incoming data flow. So the incoming data flow passes through the firewall, for example, like this BBAA, BBBBA. So what is one of the firewalls, some of the policies that are there? Permit subsequent operations of A. Another policy 1 is deny subsequent operations of B. So step 2, the firewall searches for matching security policy. Firewall determines whether to allow the next operation. So you remember we said that it will check the packets individually, independent of each other. So it will process the data packets according to the rules defined by the security policy. So you can see right now only the A's are going through, because any subsequent operations of B are supposed to be denied. If it was opposite, deny subsequent operations of A, but only allow subsequent operations of B, then that would be what would happen. So some of the function of firewall security is to filter traffic passing through the firewall according to some of the defined rules, which you will have defined in advance. And sometimes there's what we call dynamic rules or dynamic ACLs. So you'll be able to see how that really works and determine the next operations according to the keyword. So that is the mechanism of a policy. It really works. There's a firewall, there's the policies. The policies have some rules which have been defined within it and has to be followed. So remember, there's another thing about interzone. And what about interzone? You remember we talked about it earlier in the week, and we are asking each other questions. For example, can a firewall have what are we asking ourselves? Two interfaces of the same, within the same zone, 2 different interfaces within the same zone, and you said yes. We're asking ourselves, can a firewall have two zones of different security levels or something of that sort, or the same, or an interface with different rules within the same zone. So those are some of the things that come into play here. So looking at interzone forwarding, when you're looking at these, remember that a file has to check some 5 things within the packet. Remember we talked about the quantipole concept. So, and these 5 things are what? What are the 5 things? The source IP address, the destination IP address, the source port number, and the destination port number, as well as the protocol type that is there. So that is the quantipole concept within an IP packet. So so it can determine some of the packets in one data flow, and also realize that a next generation firewall, which is the kind of firewall that we really use these days, it actually can check even the users, the applications, and the schedules of the packets. So looking at this diagram, so let's look at what happens here. So there's a trust zone between the client. This is the trust zone, right? Then you have the firewall itself. So the file will query the routing table and queries interzone packet filtering rules based on the interzone. So the interzone forwarding is between the trust and the untrust, right? And direction to which the interface belongs. So if no session is matched, perform the first packet process, which is to do what? Permit packets that is coming from 192.168.0 and deny packets that are coming from 192.168.100.0. There are many other policies. Then the default interzone packet filtering rule is always deny, right? So you can see that what happens is a session is matched. When a session is matched, you perform the subsequent what? Subsequent packet process. So subsequent packet process is when you're looking at, you've had the first packet and you already have the historical information of the first packet. So what do you do? In the subsequent packets, you're now using what we call the subsequent packet process to make the process faster so that you don't check as if you don't remember anything that happened last time round. So so if it is not the first packet, because it is not, it will look up the session table and look at what is there in their mind, or what is there in the previous, and look at what rule did you apply to the last packet, because this one is not the first one. But if it was the first one, it will do what we call the first packet process and check against the rules. I hope this gets clear. This first packet process, and then there's also a subsequent packet process, and all these apply in interzone forwarding. So if it is the first packet, it has to be, if there's no session that is matching in the session table, it will be able to perform the first packet process. If there's a session that is matching, it will now perform what you call the subsequent packet process. And this is really dependent on the three-way handshake, as we already mentioned on TCP, and also independent on the quantipole concept. So there's some bit of detail about this is like a flowchart of how it works. So it will query the session table. Is there something that has matched? If there's nothing, so it will do the first packet process, and what is here, check whether a session can be created. If it can be created, it will confirm the server map table, the routing table, the packet filtering rules, as well as the NAT. Then it will create the session and forward the packet. This is happening within a firewall. If a session has been matched, it will perform a security check, update the session table, and then forward the packet. At the end of it all, it's all about forwarding the packet after you queried the session table. So it's basically how you query and create the sessions. So when you realize about stateful inspection mechanism, when you look at it, is when it is enabled, there's some two things here. When it is enabled and when it is disabled. So when it is enabled, is a session can be created only when the first packet passes the inspection performed by the firewall, and subsequent packets are forwarded based on that session. So remember that. We've already mentioned this, kind of repeating itself. Then when stateful inspection mechanism is disabled, even if the first packet does not pass through the firewall, subsequent packets can trigger the generation of a session as long as they pass through the firewall. So that means that even when that first packet did not make it to create a session, when others come through, when the other packets come later on, they can trigger the generation of a session. So it doesn't have to be the first packet only that triggers session generation. So when looking at this, you're having the host, the one who's making a request, and then there's a server. For example, this host has 10.0.0.1. It's going through a firewall, and you're having the server which needs to give a response. So what is happening here? This is the source IP, the destination IP, the TCP, these are requests, like think of it like a handshake, right? A SYN request. Then when it goes through to the server, when it comes back, you can see it'll be able to check. Okay, there's this other session where we had this, and it has been set up in the session table. And then you're going to have what? You can look at it in deeper detail here. So we're going to be having one the packet that the host is sending and the packet that the server is going to reply with. So what happens in a session? So the packet matches the session and the firewall allows the packet to pass. How? Because what happens is in this session where we're having the host doing it through port 20,000, and it's going through. You can see here what is happening. We talked about the quantipole concept. Quantipole is 5 things: 1, 2, 3, 4, 5. We've talked about next generation firewall, looking at even the user as well as the application. So you can see all these are being checked. So when you're looking at it, what is happening with regards to the session? The session is a TCP 192.168.1.1 between a TCP session 192.168.1, which is the host, and 1.1.1.1 port 23 and then port 20,000. So you can see once it has done, the file will allow still now just continue forwarding the packets the moment it sees that the rules were passed the very first time. So it makes it very easy. It ensures that the issues that were there with packet filtering with regards to processing speed is dealt with, because at that point it's just like, think of it like what? The easiest way to put it in layman language is, think of it like you have a sibling, right? Maybe a cousin. You never knew that cousin. So the first time you meet the cousin, maybe a lady or a guy or something of that sort, is the moment they come to your house, you'll actually wait. They'll actually have to knock, right? And maybe if they're coming to visit over 1 week, the moment they've left the house a bit, maybe to go and buy something in the shop. When they come back, do they really have to knock when they were really in the house? No, they don't, because they were there and they know that they've left. They just locked a bit, but they haven't put a padlock. And they don't have to knock for you to come and open for them. You'll even ask them, why are you knocking the door and it was open and you're the one who left? So that is the easiest way I can put it in layman language with regards to session within the firewall. And even it applies to dogs, right? Dogs will bark at you, but after they've understood who you really are, they'll not be so fussy on you. So this is some example. For example, which mode is this? You can tell me. Which mode is this? We learned about modes. Which mode is this? You can tell me. Yes, Mushiri, it's the user view. Yes. Yes, it's the user view. Dennis, yes, user view. So we are on the user view. So this is a command. So you can think of it like that. You can think of it like session hijacking can take place. But when looking at it, there are usually some other mechanisms. Stateful inspection is not used in isolation, but there are other checks and balances. That is why you can see I told you there's the user and the application, and this applies now in next generation firewalls. So you cannot really hijack a session if you don't even have the authentication and you really don't know the exact application that you're using. So so looking at this, the command is display firewall session table, right? So I can see the current total sessions here are 2. I can see there's a telnet. The application here is telnet. Here the application is HTTP. And you can see, I can be able to see the IP address and the port number, IP address and the port number, where it is going to, or where it is being, where it's coming from and where it's going to. For example, think of these as the host, and these as the server. Also, this is another one. You can see IP address and the port, IP address and the port. So when you want to get more detailed information, this is the brief information, you can just add verbose. When you add verbose to the command, you get, for example, this one, I can see even the zone. For example, what is different here, I can see there's a public ID, there's a zone, there's even the TTL, the time to live. For example, this one tells you even the time left. For example, I can see this one is a 20-minute TTL. Then the output interface is in loopback 0. For example, think of it like, I think this would think of it like localhost. What is the next hop? Local. You can see that is why you can see this is a local address. The MAC is a broadcast address. Packets 3073. That is, what can I say here? The number of packets, right? And the number of bytes the ones that have been received, for example, is this number of packets, this number of bytes. It was going from this IP and port to this IP and port, and the policy name that has allowed it is called test, right? So that is another way you can try to make your understanding of what is happening. The ports are usually not in isolation. Daniel, ports are usually kind of a key pair. They usually come together with the IP. So you can see packets that 3073. How many bytes? 3,251,431 bytes. Same case like that, right? So this one is an outbound interface I'm seeing here. The left is the time left for the TTL of the session, time to live. Current total sessions, I can see that one was there. And you can see it so gives you even the direction. For example, you can see VPN instance name and direction, source to destination, public to public. Yeah. So you get to understand. So some of the firewall securities and policies and application. Let's look at something here. I think this one is, so let's look at the matching principle. I think this one you've already looked at it, right? No session. I think we've already looked at it. I've mentioned this. So what happens in the first packet process, the firewall matches the packet with the security policies. In the subsequent process, the firewall does not match packets with the subsequent packets are not matched with the security policies. Once you have it, that is why you can. Once you have the sessions have been it is you're not looking at the the sessions because the session has been opened. So what is the security policy matching process? You have now the whole security policies looks like this. Usually what we call, it usually has like 4 parts. We have the condition, the action, the profile, and then at the end of it all, it says that is a response packet. You send or do not send that packet. So, for example, let's use an example here. So a traffic is coming through. What is the condition? Maybe let's look at the condition of source address, maybe the IP address. So let's say the IP address is 192.168.0.1. And when you look at it, in this policy, it says that if it is 192.168.0.1, permit. So if it is supposed to be permitted, then what happens? When you're looking at the profile, you can see it should be able to looking at it. Is it in terms of antivirus, intrusion prevention, URL filtering, file blocking, data filtering, application control, mail filtering, APT defense. So this is some of the profile of that policy, right? When looking at it, what is the policy of that? What is the policy of that? I mean, what is the profile of that security policy? Sorry. So when you're looking at it, if the action is that for this one is to be what? The 192.168.0.1 has to be permitted. You send a response packet that you send that thing. If it is to deny, maybe you deny a certain service. Maybe you are denying telnet. You don't want telnet to be working within your firewall, and you've set it up. It checks the service telnet. What do we do with telnet? You're supposed to deny. Don't send that packet. So that is how it works. So in looking at some of the different conventional security policies, the security policies within the next generation firewalls are able to distinguish between users, right? Even different departments, and it makes even network management much more granular and more visualized. Then you can be able to distinguish between applications, even within using the same protocol. For example, an application that is using instant messaging, like maybe WhatsApp, web or something. and another, maybe they're still using HTTP, and another application maybe using what? YouTube, which is maybe using for video capture or some video live streaming service or something of that sort. It can be able to differentiate that. Then it can inspect content with security and block viruses and hacker intrusion to actually ensure that it is protecting those internal networks in a much better way. So look at this security policy from our next generation firewall. This one, source address, any, destination address, any, user is marketing department, application, instant messaging and games. Anything that is going to the marketing department in the name of an application that is chatting and maybe playing games is to be denied, right? So then you have another policy here from our next generation firewall. Coming from any IP address, going to any IP address, user is what? Research we should allow HTTP, because research, they require to use the browser. They need to use the HTTP service. So when you're looking at this, you realize that this is the trust zone. This is the untrust zone, right? Think of it like the internet. So you can see if marketing department wants to do things, for example, in this, you can see it will be denied. Traffic will be denied as per this policy. If research and development department is trying to access HTTP within them, it will allow the traffic to pass through. So that is very important to know about next generation firewalls. They're able to distinguish between users, they're able to distinguish between applications, and also be able to inspect content security. So a good example here is something that, although I might not be able to show you on ENSP right now, is the zones, right? So the system usually has four default security zones. The zones that you have is, if you need more security levels, you can even create another zone. So which one are the four default? You can see they're here: local, trust, untrust, and the DMZ, right? So those are some. But if you want to create a new one, you just click on network, as you can see here. Go to zone. Then once you're getting the zone list, you can click on add and start on the process of creating a policy. So when you're creating a policy, and then you can create a zone. So when you're creating a policy, you have to do what? You have to get to have the matching conditions, the action, and also the content security profile, which can be optional, right? You remember when you were looking at it. So this is how the interface on the web user interface looks like when you're creating a. So you can see the default here is any coming from any IP, going to any IP, any port, any source port, any destination port, any user, any service, any application, according to any schedule. What is there? Deny. Remember that we said that the default action for the default security policy is usually to deny. And this is the reason for that is obviously there's no need to have a firewall that allows everything. Then you're trying to reduce what you want it to allow. It's better to start from a point where it denies everything, any traffic. Then you are now giving it what it needs to allow. So how do you can configure web addresses and groups on the web user interface? So you can just go to object, then you go to address, then you go to add. Then you can add some of the IPv4 or IPv6 addresses, which can be looked at in terms of the policy. So it can understand, okay, these are the group or the range of IP addresses that I can understand that is coming from the LAN. So you can also configure regions and region groups. For example, you can even decide that you don't want traffic coming from China or from Albania or from US. So as an example, that is, so what you can do is you can say that a region is a set of public IP addresses which are in a certain area, and a region group is what? Multiple regions or region groups, which can be configured and referenced by policy. So you can click at this, you click on object, then you go to region. Remember the other time you're looking at when you are clicking on object and going to address. But right now we are not clicking clicking on address. We are clicking on on region. Then you add the region list there. So you can configure some of the service and also in services groups. Same case, it applies the same way. You click on object, go to service, then click on add, and you can add some of the service groups there. So it'll allow me to move a bit faster here because you're not doing it practically. You're going to try it out. You have the lab guide with you, I hope. So applications, you can also configure applications and application groups. Same case, object, application, and then you can add that and click on add the way the steps are. How do you configure